Question 5.
10 slips of paper labeled from 1 to 10 are placed in a hat. The first slip of paper is not replaced before selecting the second slip of paper. What is the probability of selecting an odd number and then a multiple of 4? The odd numbers 1 through 10 are 1, 3, 5, 7, and 9. So let's start with that first event. We have a total of 10 numbers that we can draw from, and 5 of those are odd numbers. Then we have our second event. But after we've taken out one of those numbers and not replaced it, now we have 9 numbers total. On that second draw, we want a multiple of 4. The multiples of 4 are 4 and 8. So we have 2 of those. So we're going to take this fraction, multiply it by this fraction. 5 times 2 is 10, and 10 times 9 is 90. We can divide the numerator and the denominator by 10, resulting in 1/9.
Question 6.
What is the probability that a point randomly chosen in a large triangle is also in region A? So let's start with the formula for the area of the triangle. It's 1/2 the base times the height. So if you look at the large triangle, let's calculate that area first. The base is 1, 2, 3, 4, 5, 6, 7, 8. So it's 1/2 8 times the height is 1, 2, 3, 4, 5, 6, 7, 8. 8 times 8 is 64, and 1/2 of 64 is 32. So 32 square units is the area of the large triangle. Okay, the area of triangle B is 1/2 of 6 times 6. 6 times 6 is 36. Half of 36 is 18. Okay, region A. We'll calculate that by taking 32 minus 18, and we have left 14 square units. So what we want, the desired area is 14 square units. The total area is 32 square units. Divide 14 by 32 and we get 0.44. Move your decimal 2 places to the right and we can write that as 44%.
Question 7.
A and B are 2 events. Are the events independent or not independent? And explain. So for the first dot, we're given that the probability of A is 0.2 or 0.2%. The probability of B is 0.3 or 0.3%. And the probability of A and B is 0.05 or or 5/100. So the way that we prove that they're independent or not independent is to take the probability of A given B. So we'll calculate that as the probability of A and B over the probability of B. So that's going to equal to 0.05 over 0.3. Take our calculator out and divide 5/100 by 3/10, and we get, when we round that to the nearest hundredth, 0.17, which is not equal to the probability of A, because the probability of A given here is 0.2. Those were not equal, so it is not independent. Now let's analyze the second part. The probability of A given B is equal to the probability of A and B. So I'll just go ahead and substitute that in on the top, 0.075 over the probability of B, 0.3, and get our calculator out, do the division, and I get 0.25, which is equal to the probability of A, proving that these are independent events. A and B are independent.